welcome. Today we're looking at 6.4 continued. We last time talked about tangent and cotangent. Today we're going to be looking at the graphs of secant and cosecant. In order to graph the secant and cosecant, what we're going to do is we're going to graph the sine first for our cosecant and cosine for our secant. These are going to be our guides for drawing our secants and cosecants. So the sine starts at 0, ends at 2 pi, it goes up, it comes back down, it goes beneath the graph, the x-axis I should say, and it comes back to 2 pi. So it looks kind of like this. Oops, that's not very nice. Okay, that's better. All right, so what we're gonna do is we're gonna graph the sine x first. So that's part 1 for our cosecant. Part 2 is we're gonna do our asymptotes. So we have asymptotes. Wherever our graph is equal to 0. All right, so our asymptotes are gonna be here, because our graph is 0 at 0. We have another asymptote at pi because our graph is equal to 0. And then we have another asymptote at 2 pi. Because our graph is at 0 here. So where sine is 0. Okay, from there, we're going to draw our graph. So at the top of the mountain, at the bottom of the valley, those are going to be our anchor points for our cosecant graph. What we're going to do is we're going to draw U-shapes coming off the top of that. So again, the red asymptotes say that we're going to get ever and ever closer to those lines, but never touch them. All right, so technically, the graph of our cosecant is the orange part, nothing else. Like if we took away the red guidelines for our asymptotes and we took out our purple guideline for our sine, what would be left over is the actual graph of the cosecant, which is U-shaped and in gold or in orange. Okay, so likewise, when we're doing our secant, we're starting off with our cosine. Okay, so our cosine looks kind of like this shape here. Oh, I could do a better job of that. Let's do it. It looks like this. Sorry, I missed this point. Let's just kind of fix it. Okay. We're going to do our asymptotes again wherever we find our cosine is equal to 0. So we have an asymptote at pi over 2. And at 3 pi over 2. And then we're going to graph it. It's like we did the cosecant. So at the top of the hill and the bottom of the valleys. And we're going to do U-shape. So this one actually is half a U here. It's going to be half a U here. And then a whole U in between those two asymptotes. And again, the secant graph is only the orange part. The asymptotes and the cosine are just guides to help us draw these out. All right, so let's graph these two examples. If we use the cosines and sines to start off our graphs, then we should be fine. We don't have to really talk too much about anything other than that. It'll take care of itself. All right, so we have an amplitude is 2, so rather than going from 1 to -1, we're going to go from 2 to -2. We don't have an omega, so our period is going to stay 2 pi. That's our usual sine graph. And then the -1 means we're going to shift down 1. So instead of starting at 0, 0, we're going to start at 0, -1, which means we have to extend this down 1. Right, so where our normal graph would have a maximum of 2 and a minimum of -2, right? Our graph, because it's shifted down 1, is gonna go from +1 to -3, because we're starting our graph at -1. All right, so let's draw out our sine. So our sine is going to look like, let's kind of plot out some points here. So halfway would be here. A quarter of the way would be here. And then 3/4 of the way would be here. So our sine graph should look like this, kind of. We're gonna draw in our asymptote, and technically our zeros would be at these 3 points, right? If we drew an imaginary line through here. So our asymptotes are here, here, and here. Oops. And then we're going to go ahead and draw our graph. So cosecant looks like this. Okay, so notice we did shift it down -1, and technically we stretched it out too. Now let's do this secant. Notice there's no amplitude change. We're not stretching or compressing or flipping. But what we do have is, we have a change in our omega. So our period is 2 pi over omega, which is 2. So it's going to go from 0 to pi to complete one cycle of our cosecant, right? Cosecant is the inverse of our secant, our reciprocal of. We're going to split that into 4 pieces. Because there's no amplitude change or vertical shifts, the top is 1, the bottom is -1 for our cosine. Let's go ahead and graph it. So our cosine starts at the top, works underneath, and comes back to the beginning. It looks like that. We're gonna draw our asymptotes at the zeros. And then we're gonna graph our secant, top of the hill, bottom of the valley. We'll draw our U-shapes. Oops. Okay, and we're done. So you don't see a lot of secant and cosecant graphs in trig. But if you do, then we should know how to do them. And it's basically 3 steps. We're going to draw our sines or cosines. Sines for our cosecants, cosines for our secants. We're going to do our asymptotes from where our zeros are, quote unquote zeros are, right? It's different if we have something that is translated vertically, right? Our zeros would shift as well. So we have our asymptotes that are zeros, and then we take our graphs from the tops of the peaks and bottoms of the valleys, and they're U-shaped. They approach the asymptotes but never cross through the asymptotes. All right, so that's it. Make sure you have your notes taken down. Make sure you write down any questions that you have, and we can answer them next class. Good work.